For computer science students and hardware engineers, building physical circuits often begins with unoptimized mixed-gate Boolean logic. Designing a board using a combination of basic AND, OR, and NOT integrated circuits requires significantly more physical space. It complicates the routing of the printed circuit board, or PCB, traces. It also drives up the total bill of materials, the comprehensive inventory of raw materials and subassemblies required to manufacture the final product. Looking at this schematic, we see the solution: standardizing the board with universal logic. Universal logic gates are gates that can implement any Boolean function without needing to use any other gate type, specifically NAND or NOR gates. Bulk ordering a single universal integrated circuit is significantly more cost-effective than sourcing multiple specialized logic chips. Designing with identical gates also standardizes the propagation delay across the entire circuit. Propagation delay is the amount of time it takes for a logic signal to travel from the input to the output of a gate. Equalizing this delay prevents timing violations and race conditions. While you only need to source and place one single type of chip to build a massive system, translating mixed gate logic into a single universal gate type requires a tedious mathematical bridge. To map a standard sum of products expression into a NAND-only schematic, you must apply a double inversion over the entire expression. A sum of products expression is a Boolean logic format where multiple AND terms are joined together by OR operators. Once inverted, you have to apply De Morgan's first theorem to break the inversion bars and swap the internal OR operators for NAND-compatible structures. When scaling this mathematical conversion up to complex formulas containing 4 or 5 variables, tracking every inversion by hand becomes highly susceptible to human error. A single misplaced bar or missed variable corrupts the entire truth table output. Hardware engineers prototyping application-specific integrated circuits cannot afford to spend hours debugging syntax and theoretical algebra. They require a method to automate this translation instantly while maintaining mathematical accuracy. The Universal Logic Gate Converter Pro by Prime ToolHub is a digital logic studio built to automate this exact workflow. You begin the input phase by typing any standard Boolean expression containing mixed logic using the virtual logic keyboard. You can also load pre-made templates, like multiplexers and adders, directly from the sidebar. This diagram illustrates the tool's first internal process. Before executing any physical gate conversions, the built-in calculator mathematically strips away redundancies using foundational Boolean algebra rules, such as the null and idempotent laws. Raw logic equations often contain overlapping conditions. Systematically minimizing the expression first acts as a line of defense against bloated hardware, ensuring the final design maintains a low total gate count. The engine instantly translates the minimized expression into a pure NAND or NOR equivalent. It specifically optimizes NOR equivalents for product of sums expressions. Applying De Morgan's second theorem, the engine identifies AND junctions and routes the path to pure NOR operations, achieving minimal gate count. The final step in the pipeline is hardware integration. The tool functions as a dedicated compiler, generating synthesizable Verilog HDL code based on your newly optimized universal logic. Verilog HDL is a hardware description language used to model electronic systems and program field programmable gate arrays. This generated .v file utilizes standard continuous assignment blocks and proper bitwise operators. It is ready to be exported for FPGA simulation in professional environments like Xilinx Vivado or Intel Cordis, allowing you to bypass manual coding entirely. This 3-step algorithmic pipeline, algebraic reduction, universal translation, and hardware compilation, condenses hours of manual mathematical calculation into a single-click workflow. The tool's critical structural advantage for enterprise environments is its strict 100% client-side architecture. Client-side architecture dictates that all data processing executes locally within the user's web browser, rather than on an external server. Many engineering calculators operate on remote servers, transmitting your proprietary logic and Boolean expressions across the internet to generate results. Processing locally ensures the recursive parsing and Verilog generation happen in milliseconds. Furthermore, your generated code never leaves your physical device, providing absolute data privacy. Once the web page loads, you can disconnect from the internet and continue designing hardware logic. This offline capability provides a secure engineering environment compliant with corporate non-disclosure agreements. Stop wasting time manually mapping De Morgan's laws and tracking down syntax errors in your hardware code. automatically simplify your logic expressions, minimize your physical hardware footprint, and deploy identical gate arrays. Access the Universal Logic Gate Converter Pro completely for free today, only at Prime Tool Hub. Digital logic design, simplified and ready for hardware deployment.